Now we want to talk about reflections through the y-axis and reflections through the x-axis, just to be complete. Now we can accomplish reflections through the x-axis by simply doing a stretching transformation with a right negative number, but that would kind of generalize the idea. So let's start though with reflection through the y-axis. So what we do, and this is kind of a cumbersome set of words here, but it kind of gets the picture of what we're doing. We can give it a more mathematical statement, a more mathematical, well, we can give a more mathematical statement of the criterion for reflection through the y-axis. But I'm going to say we move each point horizontally. Now that means the y-axis is vertical, x-axis is horizontal, so we move in this direction or this direction along a horizontal line. We go through the y-axis until that point is at its original distance from that axis. Okay? So let's just see what that means. Let's just take a point on one of these graphs. And incidentally, I have the graphs of two power functions here. So I'm going to reflect each one. So let's just take this point on the white graph, and we're going to move it horizontally so it goes through the y-axis. Now in what direction are we going to have to move the point if we're going to make it go through the y-axis? Well, we're going to have to move it this way in the horizontal direction. If we move it that way, we're never going to get to the y-axis, so we certainly can't go through it. So we're going to come back this way for some distance. Maybe we don't have to go quite this far, but let's be careful and let's, just be sure that we have enough distance here. Okay, now we want the point on this horizontal line. I didn't do a real great job of horizontal there, but you get the idea. This is not quite parallel to the x-axis, but we assume that it really is. Okay, so we move through the y-axis, and then we keep moving until we're at the same distance we originally were. Well, how far were we? We were this far, so we've got to be this far, so that's going to give us a point here. Now that's a fairly long explanation for something that's pretty obvious. And we can do the same thing then for the other points I used to construct this graph. Okay, let's see, this far brings us this far, and I'm a little high there, but if we come this far on the other side and go just a little bit lower, okay, I'm fudging a little bit. Maybe I should have gone a little further because that doesn't look like it's going to work out. I should have. So we've got to go to about there. Okay. So I'll draw the reflection line here, and now it's a little bit low, but that's okay. All right. Now, if I've done that correctly, and then I connect these points with a smooth curve, I get the reflected graph. And now, now that I see that reflected graph, this graph appears to be a mirror image of this graph. So that's a right-left mirror image. Now we pose the question, if the original function is f of x, what's the expression for the reflected function g of x? G of x equals what? Now I'm going to reflect the other graph as well. Okay, so I'm going to reflect along this line, and this line, and this line, and this line. So if I reflect this far here, that's going to put me over here. If I reflect through this distance, that's going to put me here. If I reflect through this distance, I'm here. If I reflect through this distance, well, I'm here. So now I can sketch a reasonable graph, and again, it appears to be a mirror image. Now, if I call this function f of x, then its reflection g of x is going to have some form. And if I call this function f of x, well, g of x is going to still have the same form because the reflection through the y-axis, we haven't specified which function is which. We have the same rule for both functions. We end up getting the same expression. Okay, the other question I want to pose is, what if we do the same thing for an exponential function? Okay, so I want you to construct a reflection I was going to write a word, but there's a little confusion around what the word general means, so I'm just going to get rid of that. I don't want that word in there right now. Okay, so we're going to construct a reflection for your basic exponential graph. And then what is the expression g of x equals, assuming this graph, let's call that graph f of x. What's the expression g of x for the reflected graph? Then a couple more questions. Is this graph I should say, is the reflected graph still of a power function? Is there a doubling displacement? So you're going to want to think pretty hard about that question. It's a good question. Now, of course, I think it's a good question because I asked it. But maybe it's a good question. Okay. And is this is the reflected function here still an exponential function? If so, what happens to the doubling displacement? And of course, you can't answer this question if this isn't an exponential function. It's not a well-posed question. If this is an exponential function, which is why I say if so. How does the doubling displacement, if it is an exponential function, how does its doubling displacement compare to that of the original function?